We now begin to talk about systems of linear equations. First, let us define what is a linear equation. A linear equation in n variables, say x1, x2 up to xn, is an equation of the following form: a1 times x1 plus a2 times x2 plus all the way to an times xn equals b, where a1, a2 up to an and b are real numbers. The word linear means that all the variables have degree 1. In other words, there won't be squares, cubes, or any other powers appearing in the variables. A sequence of numbers, say s1, s2 up to sn, is called a solution to the equation if a1 times s1 plus a2 times s2 plus all the way to an times sn equals b. In other words, the linear equation is satisfied if we make the substitution x1 equals s1, x2 equals s2, all the way to xn equals sn. Let's first look at a couple of easy examples. Suppose we have a linear equation 2x plus 7 equals 5. We know that x equals -1 is a solution to the equation, and it is in fact the only solution. Secondly, if we have the equation 2x plus 7y equals 5, then -8, 3, which means that x equals -8 and y equals 3, is a solution to the equation, where we note that there are in fact infinitely many solutions to this equation. Once we know what a linear equation is, we can put together several linear equations and require that all of them to be solved at the same time. In this case, we have a system of linear equations, say there are m of them, in n variables, x1, x2 up to xn, and it has the following form. The first equation is a11 times x1 plus a12 times x2 plus all the way to a1n times xn equals b1. The second equation is a21 times x1 plus a22 times x2 plus all the way to a2n times xn equals b2. This carries on until the mth equation, which is am1 times x1 plus am2 times x2 plus all the way to amn times xn equals bm, where the aij and bi's are real numbers, I ranges from 1 to m, and j ranges from 1 to n. Again, a sequence S1, S2 up to Sn is called a solution to the system if it is a solution to every equation in the system. There are two cases which can happen. The first one is that the system has no solution. In other words, we cannot find a sequence of numbers S1 up to Sn such that it solves every equation in the system. In this case, we say that the system is inconsistent. The other case is that the system has at least one solution, and we say that the system is consistent. Let's look at a couple of examples to illustrate. Suppose we have a system with two equations, 2x plus 3y equals 8, and 5x minus y equals 3. We know how to solve this system and get the solution 1, 2, so we can say that the system is consistent. As a second example, suppose we have a system x minus 4y equals 1 and x minus 4y equals 2. We observe that the two equations contradict each other because they mean that 1 equals 2. Hence, the system has no solution, and so it is inconsistent.